John Bailey. I am a designer in a research and design group at HKS Architects. And today I'd like to present to you our journey to create what we're calling the Human Experience Lab. Within our research group, we have the unique ability to explore in-depth and complex questions that may not be typical during the architectural process, but critical nonetheless to the development of architectural space. We're able to ask questions like, how can we create a more sustainable architecture, make our workflow more efficient, reimagine how we model and document a building without paper, better interface with academia and industry, enhance the overall quality of our designs, and have meaningful impact with our projects. But the question that we're asking today is, how can we enhance the human experience by gaining a greater understanding of what those variables are which are conducive to the human experience? What qualities in architecture can enhance our ability to learn, improve cognitive function, extend our cognitive ability, and create spaces more conducive to well-being and help patient recovery time and reduce errors in hospitals? Now, to date, architectural space has largely relied on intuition, assumption, or philosophical concepts such as phenomenology to try and understand the relationship between mind, body, and architectural space. We spend the majority of our time indoors, yet we really understand very little as architects and designers about the psychological and physiological impacts of the spaces that we design. Architects and designers, by and large, make spatial assumptions based on a range of requirements, but few which take into account those physiological and psychological responses. And yet, for as much experience as we currently have to date, there are still many design decisions being made based on intuition. And I think that what we're interested in is going beyond simply just intuition and assumption at this point and trying to gain some insight into the metrics that we can use to better enhance our designs. Now, the project with the sensory lab really goes back to 2012 during a conversation with our director of research while we were working on the Brain Performance Institute in Dallas, Texas. Taking inspiration from the geometry of the brain as well as brain scanning procedures such as MRIs, in addition to environmental optimization, our design concept moved toward a geometry that was very smooth and undulating. And it was our assumption as designers that these smooth, undulating forms would have a more calming effect on patients at this institute. But in our conversations, we realized that may not be the only consequence related to the design when taking into account the range of users who would inhabit this space. At this point, our hypothesis had formed, yet we lacked the physical space and ability to understand and test these different design scenarios. We needed a space, a lab, where we could essentially mock up these design scenarios, study those effects on people, and try to understand the effects in an effort to better design this space so that it would have the positive effect we were hoping for. What remains a challenge is investigating these relationships outside of academia, in the hub of architectural practice. Within the scope of practice, it can be difficult to do deep dives, generalizable research with strictly controlled conditions. What practice can, however, serve as is a test bed for experiments within the scope of real-world projects that are pilots for more systematic investigations within academic and with industry partners. It can also serve as a testing ground for research that has been established in academia but not applied in practice. In order to have the ability to test these conditions, we have set aside a portion of our headquarters in Dallas specifically for this. And this is what we're calling the Human Experience Lab. This space will allow us to mock up design scenarios and hopefully test these conditions using a system of both environmental and biometric sensors. This is a permanent fixed lab space within our office, of which a portable sensory lab is a prototype of this condition and what will be the focus of the presentation today. In many ways, the lab is a culmination of experiments we have been engaged in on multiple levels over the years. So today we've worked on 4 experiments that I'll briefly go over with you. The first of these uses full-scale mock-ups to get user feedback to 3D built form prior to design, using full-scale mock-ups to simulate physical space and behavior scenarios to change space layout. Now we're using this currently on the majority of our projects, where we're also looking to embed sensors into the mock-ups so that we can have a direct link to our digital models. The second one merges human activity data into a sequence simulation tool. Using data from field research, such as nurse walking paths or staff walking paths within a hospital, we can use this information to directly inform our parametric planning process. This simulation has now become standard practice in all of our healthcare projects to inform real-time decision-making. The third experiment uses EEG signals to manipulate physical and digital form. Utilizing commercially available EEG hardware and building a custom interface with our parametric modeling software, we're exploring the possibilities of manipulating digital models and physical building systems based on neurological input. We are in the exploratory stages of this project currently, but you can see this is a short video. On the left is our parametric modeling software. In the command window in the top left is data coming in from the EEG headset, and we're simply just using neurological input to manipulate the physical model. In this case would be like a sun shading system. And so we're looking at the possibilities of how neurological input could potentially manipulate physical form and building systems within the sports and entertainment arena. So we're currently developing a prototype for a sensory design lab where we can track human responses to environmental changes in real time with continuously monitored environmental and physiological outcomes. Our vision with this grant-funded project is to create a flexible, trackable, and transportable space so that testing can be done at client sites next to where the ultimate users are. We are looking at cataloging environmental variables such as room volume, air quality, noise, temperature, the texture or level of detail, relative humidity, lighting, level and quality, also color and furniture configuration. We're also looking at biometric variables such as mood, movement, performance, stress, and anxiety. Working with the Dallas Independent School District through an American Society of Interior Designers grant, HKS has the opportunity to construct a prototype sensory design lab which can test scenarios with students in their school. The school is currently exploring personalized learning through a Bill and Melinda Gates Foundation for grades 9 and 10. And for this particular study, our lab will be housed in the renovated second floor of the DISD school. The intent here is to create a flexible lab space, something that to our knowledge has not been done before, where the wall systems and framework provides a level of flexibility that allows design teams to test out different configurations and assess the impact on human outcomes. When considering how this lab would manifest itself, we still have questions and see opportunities across the spectrum of technologies, processes, and potential scenarios. This ranges from what I will say is the low fidelity to the high fidelity. When considering physical mock-ups, we are considering a range of options from simple cardboard mock-ups to higher fidelity as-built constructs. Simultaneous to this, we are considering the digital arena for experimentation, from the use of virtual reality goggles to cave systems. We are also asking the question, what is the applicability and discrepancy of one system versus another? Does a low fidelity physical model have the same impact on human perception as a high fidelity virtual walkthrough? Can we learn enough as designers from either of these systems to make credible design decisions moving forward? In practice, these spaces may overlap just as the role of the designer may merge. However, the science of systematic inquiry must be balanced with the art of creative thinking. And so we must ask the question where those two meet. Now, we have been working through many of the challenges as it pertains within research within a professional setting, some of which is a difficulty in finding and working with the industry to find a brand agnostic framework that is both flexible to test out different design scenarios.
Are you representing this entire panel?
Yes. I'm John, yes. What systems offer us the ability to test various lighting conditions, spatial conditions, materiality, and thermal conditions? And we also have to think about the cost versus the value for each individual project. What makes more sense for the budget of the project or the scope of time that we have? Are we able to get into a low fidelity versus a high fidelity model? And what will likely give us the most useful information to inform design decisions versus the cost of that system for a particular project? We also must be cognizant of sound isolation and when we're working within a collaborative environment such as our office. And thinking further about how do we balance flexibility with the need for actual work surfaces? And when considering the technological capabilities we have to date, what makes more sense for a given project? And how does an experiment done in physical reality versus one done in a digital reality or virtual differ on human perception and measurable outcome? How is a VR cave or goggles more or less successful than a physical prototype? The idea for a physical space, a hybrid lab studio, emerged through a need to create tangible, physical, three-dimensional environments which we can test with evolved sensor technology. There were three critical components that were initially designed and identified for this human experience lab. The three spaces that we looked at were a think space, a space where designers and researchers could come together and ideate and explore and innovate. Also a maker space, a space where designers can create three-dimensional realities based on dialogues with research teams. And thirdly, a test space, a space where researchers can test the efficacy and design solutions to inform new iterations. What we are looking for here today are meaningful collaboration opportunities, people who see the potential and relevancy with this line of work. If you have more information or would like further discussion on this project and how we could potentially collaborate, please come find me at the end of this. Our intent is to be completely transparent and collaborative in our initiative because research and innovation cannot happen in silos. Thank you.
We have time for a few questions.
Thank you. I'm Diane from Interior Architects. I'm an architect. I was wondering if you could talk more about that interface between the person looking at the shade controls.
Yes.
Yep.
Please.
Yeah, so for that particular experiment, we were using the emotive epoch with the development kit. And so with that, we're working with our modeling platform, which is called Rhinoceros. It's a visual programming tool that we use. And so basically, he is programming different variables into the EEG headset, and we're translating those directly into our digital model. And so we're using environmental software in conjunction with that so that we can try to block a sunshade in that case. We also see potential for other devices such as using ferrofluids within a membrane of a stadium roof so that we can actually start to manipulate those. Or when we think about how a crowd within a stadium may, through the crowd, start to inform physical systems or building systems within that. And so that was just one of the first digital tests that we had done just to make sure that we could get the data out of the EEG headset and into our modeling platform.
That's fascinating. Thank you.
Any further questions?
That was fascinating, thank you. Pam Cole, BAM Architecture Studio. I run the business, not the architecture side. So I'm curious to hear about collaborations that you've had with clients that could co-fund this kind of research to move it forward in the real world.
Are you speaking specifically to the sensory design lab or some of the other experiments that we've been looking at?
Open it up to you.
Okay. Some of the healthcare projects that we've been working on, most of them are larger healthcare projects where we're able to create the sort of mock-ups because it takes a lot of coordination and time to be able to get nurses and staff into a warehouse basically to test these scenarios over the course of several months. In the case of the Sensory Design Lab, we had been working on this collaboration with the Dallas Independent School District for a number of years, which eventually led to them receiving the Bill and Melinda Gates Foundation to explore personalized learning with 9th and 10th graders. From there, we were able then to further secure another grant through the ASID to help work on this project. But we also have received some in-kind donations from other partners such as Herman Miller that we're working with currently. But so far on the client side, it's mainly in the realm of healthcare.
Thank you very much.
Thank you.
Applause.